Here I'm going to go through a Leaving Cert past paper question on sequence and series. It's from 2018, paper 1, question 5. You're asked to find the difference between the sums of the first 45 terms in the first two rows. So we've got row 1, row 2, etc. And this is column 1, column 2, etc. Okay, so what we need to do is we need to have a quick look at the tables and remind ourselves of the formula that we're going to be using for sequences and series. If we look at the bottom half of this sheet here, we've got sequence and series. When you've got an arithmetic sequence, you've got a pattern that is increasing or decreasing by a constant different amount. Okay, so to find any term in that sequence, we look at the first term, which is called A, and we add then the number of terms minus 1 times the difference between the terms. If we want to find the total sum of the first n terms of that series, we use this formula. For the geometric then, that's when we have a pattern that repeats, but each successive term has been multiplied or divided by a certain amount. So in that one we have a constant ratio. So to find any term, Tn, we just take the first term, which we call A, and multiply it by the ratio to the power of the number of terms minus 1. Likewise then, we can also find the sum of the first n terms by just fitting it into that formula there. We can also get the sum to infinity if we have a geometric sequence where the modulus of or, so or is the ratio, is less than 1. So essentially what that means there is we don't have a sequence which is just expanding infinitely. We have a sequence that has a limit. So as the number of terms gets bigger and bigger and bigger, we can add up all those terms together and find out what the total sum of those terms would be. Alright, so let's go back to the question then. Because we're dealing with an arithmetic sequence here, we're going to be using this formula to start with. So, find the difference between the sums of the first 45 terms in the first two rows. We're going to be looking at row 1 and row 2, and we're going to find the sum of the first 45 terms. So, the sum of the first n terms, let's remind ourselves for the formula, is going to be n over 2 outside of 2a plus n minus 1d. For row 1, sum of the first 45 terms is going to be 45 over 2 times twice the first term, which is 4a, plus n minus 1, so that's 45 minus 1, so 44 times the difference. Well, the difference in the first row, it goes up by 3 each time, so the difference there is 3. And that gives me a total of 3150. And for row 2, the sum of the first 45 terms, we just do the same formula, except now we're starting with 2 times a, we start with 7 plus 44 again, because it's n minus 1, times the difference. And in here, the difference between 12 and 7 is 5. So again, we just plug that into the calculator and we get a result of 5265. Alright, so we're looking for the difference between the sums. So essentially we just need to subtract those two numbers. So 2115 is our difference. For the next one, find the number which is in the 60th row and the 70th column in the table. Okay, so we need the number that's in the 60th row. If my rows go down like that, I need to go down to the 60th row. So I need to find the first term, which is term 1, in the 60th row. So essentially I'm going to be taking this column and finding what is the 60th term in that column, because that gives me the 60th row. In column 1 I want T60. So that is going to be, well, let's remind ourselves, Tn equals a plus n minus 1 times d. So it's going to be T60 equals 4 plus 59 times 3. That's equal to 181. So if that's my 60th row, that term there is 181. I'm looking for the number which is in the 60th row, but also the 70th column. So I need to go across to kind of the 70th column down there, and I need to find that number, which is the 70th column and the 60th row. So I'll need the 70th term in row 60 essentially. Then the only thing I'm missing then is the difference in the 60th row. So I need term 2 in the 60th row. So I'm now looking for that. So term 2 in the 60th row is also going to be the 60th term in column 2. That's going to be 7 plus n minus 1, which is 59, times the difference in the second column, which is 12 minus 7, which is 5. And that gives me 302. So that number there is 302. So I now know something about this 60th row. I know the first term and I know the second term. So if I know the first two terms, I can work out the difference. The difference is the difference between those two numbers. I now need term 70, because that's the 70th column in row 60. So I now need term 70 for that 60th row. Well, it's going to be a plus n minus 1 times d, and the first term was 181 plus 70 minus 169 times the difference between 302 and 181, which is 121. And all of those together give me 8530. That is the term which is in the 60th row and the 70th column. So now we're going to look at the next question here. The first two terms of a sequence are 4 and 2. The general term is described by a to the n minus 1 minus a to the n minus 2. So essentially, to find any term, we need to take the preceding term and subtract the term preceding that one when n is greater than that. So a1 equals 4, a2 equals 2, a3 is equal to the preceding one, which is 2, minus the one precedes that, minus 2. So these are my terms: 4, 2, minus 2. A4 equals minus 2 minus 2 minus 4. I'm to write out the next 6 terms. So A5 equals minus 4 minus minus 2 equals minus 2. I'm just trying to conserve space here. So A6 equals minus 2 minus minus 4, which is minus 2 plus 4, which is 2. A7 equals 2 minus minus 2, which is 4. And the last one, A8 equals 4 minus 2, which is 2. So they are the next terms, and find the value of the 2119th term. Okay, so let's just write these all out. You got 4, 2, minus 4, minus 2. So we're looking for a pattern here. 2, 4, 2. We can see here it started to repeat itself after 6 terms. So here, looking for the 2019th term, as it repeats itself every 6 terms, we need to take out all the multiples of 6, essentially, out of that term. So if there are 2019, we're looking for term 2019. We know that that goes into 336.5, as there's a remainder of 0.5, and half of 6 is 3. As there are an even number of multiples in 2016, that must be the 6th term. So 2017 would be 4, 2018 would be 2, so 2019 is the number minus 2. So essentially we just needed to take out all the times that it's repeating itself there and see where the term started as close as possible to 2019. And it started at term 2017.